Welcome back to another episode of MRP Easy Manufacturing Podcast, a podcast that is tailor-made for people working in manufacturing. We will bring you tips from industry specialists and keep you updated on the latest trends. In our 16th episode, we're talking about make-to-order and assemble-to-order manufacturing process flow and best practices. Nothing is more exciting for small to medium manufacturing companies than to see their products take off and their operation begin to scale. And as companies begin to scale, they should be keenly aware of the mode of production used to manufacture their goods. There are many production modes available, and often the products or the market will determine which mode is required for a manufacturer. 3 of the most common modes of production are make-to-stock, or MTS, make-to-order, MTO, and assemble-to-order, ATO. Make-to-stock is used for high-volume goods, commodified products, consumables, and other product types where consumers purchase the same version of a product as a single unit or in bulk. It is a push production method used to provide a steady supply and stock for retailers. Of the remaining 2, make-to-order and assemble-to-order are similar. Make-to-order is a manufacturing mode where production begins once an order is received. It is a pull-type production mode where demand in the form of an order triggers production. Make-to-order is used on goods where the order is a quantity of one or a few, and in situations where all or part of the order may be custom-made or carry a high unit cost. Many of the components and raw materials may require sub-processing or rendering before they find their way into the final product. Assemble-to-order may follow many of the same steps as make-to-order. However, in assemble-to-order, few, if any, sub-processes are required, and units are assembled from completed components to make a whole unit. In make-to-stock modes of production, planning and scheduling are the triggers for production. As a result, sales orders are linked to warehousing and bulk stock levels. Production and supply chain efforts are geared toward replenishing the stock required to keep the outbound orders supplied and in anticipation of new orders. The entire system requires a buffer or safety stock aspect that exists throughout the operation. Raw materials and components are purchased in bulk and on hand to keep production moving at a predictable level. Production also creates buffers in the form of work in process, or WIP, to keep things moving and balanced. In both make-to-order and assemble-to-order, different strategies are required. In these modes, the sales order is the trigger for production. Because of this, these modes require much closer coordination between vendors and production. In make-to-order and assemble-to-order, purchasing, logistics, and lead time are key, as there is often much less inventory of components. They are excellent modes for use where finished goods may have different customer-defined variant configurations, or where materials are segregated, meaning they will only be used in a specific product for a specific number of units for a defined customer. Advantages of make-to-order and assemble-to-order include cost. Because there is little to no safety stock set aside to produce volume targets, and because the production environment does not require a large amount of WIP, cost of make-to-order and assemble-to-order is lower than some make-to-stock modes. Make-to-order and assemble-to-order environments require less cost in the form of raw materials warehousing space and staff. Specialization. In make-to-order and assemble-to-order environments, orders can be made specific to customer requirements. Finished goods inventory. In a make-to-order or assemble-to-order operation, orders produced are already sold. This prevents the manufacturer from having to carry slow or no selling units. This impacts costs in the form of warehouse space and staffing for finished goods. It also impacts cash flow and tax liability, as no unsold units are left to tie up valuable cash over time. Manufacturers who deploy make-to-order and assemble-to-order should be cautious in their planning, as they can provide some headaches depending on the demand signal. Disadvantages of make-to-order and assemble-to-order include low supply. Since orders are produced as they are received, make-to-order and assemble-to-order does not have a ready supply of units for purchase. In strong seasonal demand, or if a model or product becomes widely popular, the lack of current availability may result in lost sales. Lead time. As make-to-order and assemble-to-order are built on demand, lead times are longer for products than in a make-to-stock. To maximize the effectiveness of a make-to-order or assemble-to-order production mode, small to medium manufacturers should adopt best practices to realize benefits. These practices include such things as a robust ERP or MRP system. Since make-to-order and assemble-to-order modes are triggered and driven directly by sales orders, a robust ERP or MRP system is required. The platform should have a strong linkage between its sales order and production planning functionality. Using the functionality can ensure the ability to keep customers informed and can also be used to accurately monitor inbound materials to create a seamless end-to-end customer experience. And materials planning. Make-to-order and assemble-to-order production modes are excellent for perishables, custom production, production with high unit cost, and production where materials are segregated and only used for the orders for one customer. However, this doesn't mean that all components are segregated. Most assemblers and manufacturers use raw materials and components that are interchangeable or common to many of their finished products. Purchase planning can therefore be smoothed out for vendors with long lead times for common parts, not to create an inventory buffer, but because the commonality of the part combined with the usage reporting will allow a steady stream of parts on a just-in-time or JIT basis. One example would be a wire harness that is used in all models of a manufacturer's products. Where used reports and consumption history can be used to plan inbound replenishments even though the finished goods will not be produced without sales orders. And if materials and components are segregated for some or all of an order, meaning unique to that customer order, then establishing very close and well-defined vendor relationships are critical. Scheduling and planning. A strong scheduling and planning system available through ERP and MRP systems will help plan production schedules at optimum levels. For one, relying on common parts and materials as mentioned in materials planning above will allow consolidating or combining production orders within the production workflow. Just because each unit produced must have a sales order doesn't mean that it can't be combined in production with other units being produced to take advantage of the commonly used parts and materials. Another best practice is to utilize backward scheduling. Within many ERP systems, there is the ability to input due dates for the completion of orders and have the system generate manufacturing orders to meet those dates exactly. This helps to build just-in-time practices within the supply chain and manufacturing workflow simultaneously. Cost. Modern ERP and MRP systems can roll up costs accurately for custom orders. This accuracy allows managers to focus on process improvements in measured labor, waste reduction, maintenance programs, and others that will help lower variable cost for the products. And finally, as make-to-order and assemble-to-order leave little to no stock in the warehouse. Iteration changes to existing models do not trigger retrofitting of finished goods inventory. With a strong ERP platform, changes can be implemented on next unit up to begin production with included changes immediately. Further, lot tracking and the ability to query and generate reports within the system allows a company to follow subtle design changes throughout the life cycle of a product without obsoleting inventoried finished goods, as there are none. In summary, mode of production is often dictated by the market or product produced. But once the mode is set, the best practices can be combined with a robust ERP system that uses intuitive toolsets, adaptable and agile functionality, and predictive analytics to provide small to medium manufacturers the tools to build an efficient manufacturing process flow to handle any level of scale. This episode of MRP Easy Manufacturing Podcast has come to a close. Thank you for listening. Make sure to subscribe for more manufacturing tips or visit our website at mrpeasy.com for more information about us.